Hey folks, welcome back to another video. Today we'll be looking at question 1345, jump game 4. The approach that we'll be using for this problem is DFS. So let's jump right in. The first thing that we will do is we'll create a hash map. And what we're doing with the hash map is we are storing a particular value that we've seen in the array itself and all of the indices at which it occurs. So let's just initialize that. Integer map, hash map. Next thing we do is just get the size of the array so it's easy for us to access that. The next thing we do is we add all of the elements to the hash map. Map dot, and we will be using compute if absent, and the reason why we're doing that is because we have to initialize a new object. So we would be adding the element itself and then a new linked list, and you would add the index at which it is occurring. So since it's DFS, there are two things that we need there. The first thing you need is a queue. Linked list. Okay, and the thing that we'll be offering to the queue is the first index because that's where we will be starting. The next thing you need is also an array of Boolean values that would tell us if we have visited a particular value or not. So new Boolean, yeah. Right, and then let's just set that to 0. True. Okay, what are the other things that we would possibly need? Yes, the result itself. So let's initialize the number of steps to 0. So since this is BFS, the loop that we'll be using is a while loop. So while queue is not empty, we will be doing certain computations, and the main part of the solution would go right into this while loop. And if we haven't returned a solution by then, we would have to return -1. Okay, cool. So let's get started from here. So in size is equal to q.size. And what we will be doing is we will be iterating over all of the values in the queue with this. So have we used I before? So int I is equal to 0, I less than size. And the reason why we do this before the queue is because since we'll be adding new values within this while loop, the size of the queue keeps changing. So you need to, with every iteration in the while loop, you need to get the fixed size of the queue and go over that size. Alright, so what are we doing here? As soon as we come to this condition, let's pull the current value. Q.pull. And we check, hey, is current value equal to n-1? That means have we reached our end, our last condition? If yes, we would just return the step. If not, we continue computing. So let's say list of integer adjacent values is equal to map.get array of current. So the reason why we're getting is that doing this is because we want to get the list of all the indices at which we have the same value, and since we can also traverse to the index before or after, we would add that as well. So adjacent.add current of +1 and adjacent dot add current of -1. And the reason, and I do realize that you need to check whether it's greater than 0, greater than equal to 0, or less than the size, but we will do that in another loop. So once we have this list right here, we know all of the indices to which the current element could traverse through without a problem. So we will iterate through that. So for int I in all of the adjacent, we check. So if a is greater than or equal to 0, and if a is less than n, and a visited of a, if it is not visited, then we will do a couple of things. We will mark that as visited, and we will offer that to the queue. And once this is done, once this for loop is done, what you want to do is that you want to clear this next, this adjacent area of everything. Clear. The reason why you're doing that is because since this will be looping over again, you want to make sure everything is clear. And one last thing that you have to do is you have to increment the step. Once this for loop is done, you want to increment the step because, hey, these are the number of steps that we have taken. I've taken one more step, so that's the reason you're incrementing it. So let's just quickly run this and see if it is okay. La-di-da, la-di-da, da-da-da-da. Oh, new. Okay. Okay, cool. So the first test case passes. Everything passes as well. The time complexity of this entire solution is O of n because you'll be iterating through all the elements in the array at the most twice, here once when you're actually adding it, and here once as well. The reason why I would be iterating over it just once is because we have the visited the Boolean array, and then the space complexity is also O of n since we are storing a few additional data structures for our BFS solution. I hope that helped you with solving this problem. If you have any other questions that you want me to solve, please let me know in the comments below. Don't forget to like, share, and subscribe this video, and I'll see you all in the next video. See you guys, have a good day.